Assalamualaikum warahmatullahi wabarakatuh. We continue with chapter 5 on applications of integration. So this topic will cover two main ideas. The first is on finding the area and the second is finding the volume. So we'll start first with the area. You may refer to your textbook page 273. So given here is the idea on finding the area when cross-section parallel to y-axis. Right, so consider here if you have one function. So let's say this is our straight line function. Okay, one function in your graph. So maybe we can put this is for your fx function. Okay, and then we have another function. Here is your gx function. So now let's say we want to find the area, okay, bounded between these two curves. And given this cross-section is parallel to y-axis. So what does it mean by cross-section parallel to y-axis? Meaning that we are going to make a straight cut through here that will parallel to y-axis. So finding the area, we are going to apply the idea on integration, right? So given here, integration from A to B. Okay, your x from A until B. So for any equation, you are given the bounded, or if you are not given the bounded, you need to find that one first. So let's say this is your A and this is your B, right? So finding the area for this, you need to consider the integration from A to B. For what? For two functions given, you need to identify the upper and also the lower function. Okay, so from the graph. Now, the cross-section parallel to y-axis, meaning that we are going to integrate with respect to x-axis. Since it is x-axis, so here we are going to use the x. Alright, so now, in order to let you identify the upper and lower function, so this is our first function. The highest function exists in our figure. And this will become the lower function. Right. So now from here, this part, we are going to go down until x-axis. So that's why we are going to decide the first functions to be fx. So this turn to be your upper function. So here will be fx first. Okay, so the second function to becomes your lower function, this one, and then goes to your axis. Right, so this will be your lower function. Okay, so we are going to minus with gx function. So this is the formula of finding the area that cross-section parallel to y-axis. So if you refer to the above formula stated in your textbook, okay, integration from A to B for this fx minus gx with respect to x. Okay, so this is the first formula that we are going to consider, and then we will continue with the example. So example 1, given R is the region bounded by the curve y equals to x squared. So this is our first curve. And the line of 2x minus y plus 3 equals to 0. Okay, and also this line. Find the area of the region R. Now look at this region. So consider this is your line, right? Okay, this is your straight line involved. And this is the curve involved in the figure. Finding the area, it is focused on actually area under curve. So below this curve, let's say we consider this straight line to be our fx, right? And this curve be our gx. So obviously, the straight line will become your upper function, is it? So this will become your upper function, and this will become your lower function. Or if you want to check in terms of cross-section parallel to y-axis, So here is the figures given to you in terms of cross section, right? So let's continue for this. In order to find the area, okay, for this example given to you together with the coordinates. So you are given these coordinates, right? Okay, both coordinates. If you are not given the coordinates, how to find these coordinates is finding the intersection between these two equations, meaning that you are going to solve equating the first and second equation, then finding the x and y coordinates. Okay, so back to this. Our area will be the integration from x1 until x3. So if you refer to your figure just now, this one, this is where your x is equals to -1, and this is the value of x equals to 3. Okay, so that will be your a and b value. So that need to decide fx or gx or upper and lower function. So the upper function will becomes this straight line of 2y minus y plus 3. So when we want to find the integration with respect to here dx, right? So here is dx. So all variable involved must be in terms of x. So what we need to do is we need to rearrange the given equations in terms of y as the subject. So that's why here you can get y equals to 2x plus 3. Rearrange from that, from 2x minus y plus 3 equals to 0. So if you move this y to become positive, so that 2x plus 3. So this is the equation in terms of y as the subject. And the second equation given to you is y equals to x squared. So this is clear, it doesn't matter, all variable x. So now since our upper function is the straight line, so we are taking this 2x plus 3 to be the fx function. So this one will be your fx if you want to compare as given in the formula. And the second part of that, this x squared, right? This value will become your gx. Right, okay. So 2x plus 3 minus x squared. So this is simply nothing to simplify here, right? So you just need to proceed with the integration step. So this is a simple function. So integrations of 2x, you will get 2x squared over 2, right? So that you can simplify this. So here left with x squared. And integration of 3, obviously you will get 3x. Integration of x squared, you will get x to the power of 3 divided with 3. So next is about substitution. Evaluate for -1 and 3. Right. So just substitute and calculate. So you will get this value 10/2/3 as your final answer. So this is the answer for the area bounded by this curve. Okay, meaning that you are done finding the area for this region.